So as we keep looking at our sum and difference formulas, one thing that we can do with this is prove things, okay? Anytime you get some kind of a formula or whatnot, when mathematicians are using this, they'll say, okay, well, what else could I do with this? Is there something else I can do? We're actually going to do this tomorrow when we look at the double angle formulas, okay? But one example of an identity that we've already looked at is the cofunction identity, okay? The cofunction identity, cosine of pi over 2 minus x equals sine, we can prove using our difference formula.
Oh, so you would do like cosine of pi over.
So it'd be cosine of
Pi over 2.
Pi over 2.
And then it would be cosine of x.
Negative x.
No,
Or no.
No, just
Oh,
x.
that's right, never-
And then it would be plus.
Sine of pi over 2 times pi sine of x.
That's okay.
Very good, okay?
Pretty slow.
So, cosine of pi over 2 minus x equals cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. Alright, now we can use our unit circle. What's the cosine of pi over 2?
1/2 is. No.
3 over
3
0.
over 2. 0.
0.
Wait, pi over 2 or?
Pi over 2.
Oh,
It's okay.
0 times cosine of x
it's on video.
plus, what's sine of pi over 2?
That's 1.
That's 1 times the sine of x.
Oh, cool. And then 0 times cancels out.
So that's all 0.
Wait,
Sine x.
0.
Da 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 da. We've got it. Okay.
No. Wait, why did I
I'm
cancel out?
lost.
Because 0 times anything is 0.
We got to know our unit circle here. Okay.
Right.
So,
We actually can prove it the other way as well. You remember that the sine of pi over 2 minus x equals the cosine of x. Well, if we used our angle difference formula for sine, it's, remember, sine of u times cosine of v. The operation matches with sine, so it's minus the cosine of pi over 2 times the sine of v. Alright, well, what's sine of pi over 2 again?
sine of pi over 2 is 1.
Come on, 1. So 1 times cosine of x. What's cosine of pi over 2?
0.
0. Okay? Times sine of x, which of course that's all 0, and we have just cosine of x. So we proved that one as well.
So you just
Okay.
switched that around for just to show.
Yeah, just to show, we could have done either of those. Now the other ones may take a little bit different. You may have to deal with a little bit differently, the cofunction identities. So like the secant, cosecant, the cotangent, and tangent, those ones work a little bit differently. But sine and cosine you can prove with this. Okay. Another thing is we have these things that are called reduction formulas. Okay? We have a case where we have cosine of theta minus an angle. Here it's cosine of theta minus 3 pi over 2. Or another case where we have tangent of theta plus 3 pi. And by using our identity here, or our formula, we're able to simplify this down into something that's a little bit easier, okay? So for example, cosine of theta minus 3 pi over 2. Let's use our formula. What would it be?
It would be cosine of theta
No, Evan.
Cosine of theta,
times cosine of 3 pi divided by 2
okay?
plus sine of theta times sine of 3 pi by 2.
Okay, good. So now we just have to figure out what these values of sine and cosine are. Alright, we got cosine of theta times, what's cosine of 3 pi over 2?
0.
0. Plus the sine of theta, times, what's the sine of 3 pi over 2?
Negative 1.
-1. Good, -1. So of course that's 0, and this whole thing equals a negative sine of theta. So the cosine of theta minus 3 pi over 2 is sine of theta.
Negative
Negative sine of theta.
That's
no? No way.
the answer to this. Like, what do you?
Yeah, we simplified
Oh, it's-
this so that we just had something in terms of theta instead of having it as a theta minus whatever.
Okay.
Okay? We could do the same thing with this tangent. Tangent of theta plus 3 pi. Okay? So our tangent formula, what would this equal here using our tangent formula?
Tan of theta.
Beta plus tan of 3 pi.
Yeah, tan of 3 pi over
1 minus tangent
of.
theta times tangent 3 pi.
Yeah, that's right.
Alright, good. There's our tangent formula. Okay? Now, all we have to do now is figure out what tangent of 3 pi equals.
I got you.
What is it?
Isn't 3 pi?
What's 3 pi?
Is it
Something
anything
squared
else?
plus
Oh wait, no, it's the other.
one. It's gonna be 180. It's gonna be negative
It's
Negative
sine over.
Doesn't it go around?
It's gonna be
One
0 over
negative
negative 1. 0
Negative
over
one.
negative
So it's gonna
1.
be
0 over negative 1.
Oh yeah.
No.
Because it's
which
like
is
doing
0.
180 degrees.
No, 0
Zero.
over negative 1 would be 0. Okay?
Yeah, you
Negative
said
one.
that.
How did you do that?
So,
No.
let's talk this through real quick.
Oh,
Three
did you say
pi.
tangent of that?
1 pi, 2 pi, 3 pi.
I was right.
Oh, okay.
So, yeah, you had the right point. Negative 1, 0. Sine is the y coordinate, cosine is the x. So it's 0 over negative 1. So, this is 0, and this is 0. So if you look closely here, we have tangent
Theta over 1 pi.
plus 0
Tangent of.
over 1 minus, you're right, over 1 minus 0. Because 0 times tangent theta would be 0.
Plus 0?
Okay? So, we just have tangent of theta.
This is.
He's cool.
amazing.
Okay? Now, real quickly here, do you guys remember the graph of tangent at all?
Yeah, it's
Yeah.
like
Yeah.
Had those asymptotes and whatever?
Oh,
Yeah.
So it hits it at the pi.
Do you remember the period of tangent?
It's
Pi. The period of tangent is pi. We actually just showed that working here. Notice if I'm adding 3 pi, I'm going 3 periods down the way, I'm going to end up at the same spot as I was at tangent of theta. Okay, because the period of tangent is just a pi instead of a 2 pi. Okay? So, another interesting observation and a way that we can relate the graphs of these back to this more algebraic approach. Okay?
I love algebraic approaches.
So,
Fun fact.
that's it for this. The one thing I do want to point out here, okay, we've looked at some similar to these. On these, what are you going to do before you start using your formula?
Simplify the inward thing.
Simplify those inverse trig functions. So you know that the inverse cosine of negative 1/2 is,
just 1/2. Negative 1/2.
no, we're looking for an angle
Wait, what are you asking?
Oh.
whose cosine is negative 1/2.
It
That
is
means it's
1/2.
4 pi, so
It's
it's
1/2.
2 pi over 3.
2 pi over 3, yeah.
Right?
2 pi over 3.
Good job.
Okay?
You're right.
So this is cosine of 2 pi over 3 plus, what's the inverse sine of 1?
Pi over 2.
Pi over 2. Okay, so you got to do this first before you can use your formula. Figure out what angles you're working with before you try to use your formula. Okay? The other thing I'll point out is down here. You're going to use your formulas first, and then you're going to need to solve the equation. Okay?
Calculator.
So, solve your equation. Do it algebraically. If you want to use the calculator to check your answers, you can, okay? But you should be able to do this algebraically, using your formulas, using your unit circle. After you use your formula and your unit circle, though, then it's just back to the same types of equations we were dealing with. Try to get it all in terms of one trig function, you know, all of that kind of stuff.
Okay.
Okay? So, I'll give you guys the rest of the time here. You can get going on this.